Running a web server inside a VM. Web servers play a crucial role in hosting websites, applications, and APIs, making them an essential component of modern IT infrastructure. Setting up a web server inside a virtual machine, VM, allows developers, system administrators, and IT professionals to test configurations, deploy applications, and simulate real-world web environments in a controlled and isolated setup. When hosting a web server inside a VM, two of the most commonly used web servers are Apache and Nginx. Both are widely adopted, highly flexible, and offer extensive customization options for serving websites efficiently. Apache is known for its modular structure and compatibility with various applications, while Nginx is preferred for high performance, load balancing, and handling concurrent connections. The choice between Apache and Nginx depends on server requirements, workload demands, and specific use cases. Why use a virtual machine for web hosting? A virtual machine provides a secure and isolated environment for running web servers. This makes it an ideal choice for development, staging, and testing, as changes made to a VM do not impact the host system or production servers. Developers can safely experiment with configurations, install software, and troubleshoot issues without affecting other components. Another advantage of using a VM for hosting a web server is hardware abstraction. Since VMs run independently of the host OS, they can be moved, cloned, or backed up easily. This flexibility is particularly useful for testing different server setups, benchmarking performance, and simulating real-world traffic scenarios before deploying to a live production environment. Security is another major benefit of running web servers inside VMs. A compromised VM does not directly expose the host system to security threats. By implementing network isolation, firewall rules, and access control mechanisms, administrators can contain security risks and prevent data breaches. Additionally, snapshots and backups can be used to quickly restore the server to a working state in case of misconfigurations or cyber attacks. Apache versus Nginx, choosing the right web server for your VM. Both Apache and Nginx are powerful web servers, but they differ in how they handle requests and process web traffic. Apache follows a process-based architecture, where each incoming request spawns a new process or thread. This makes Apache highly compatible with dynamic content, such as PHP applications, CGI scripts, and legacy web services. Apache is widely used for shared hosting environments and smaller-scale websites where modularity and flexibility are key priorities. Nginx, on the other hand, is designed with an event-driven architecture that allows it to handle thousands of concurrent connections efficiently. This makes Nginx an excellent choice for high-traffic websites, reverse proxying, load balancing, and handling static content. Since Nginx consumes fewer resources than Apache, it performs better under heavy workloads and high concurrent traffic conditions. The choice between Apache and Nginx depends on factors like workload type, expected traffic, and resource availability. Many production environments even use both servers together, with Nginx acting as a reverse proxy to handle static content and forward dynamic requests to Apache. Networking considerations for running a web server in a VM. Networking plays a crucial role in ensuring the accessibility and performance of a web server inside a VM. When setting up a virtual web server, proper network configurations must be in place to allow external devices to access the hosted website. There are three common networking modes in virtualized environments. NAT, Network Address Translation. This mode allows the VM to connect to the internet using the host machine's IP address, but external devices cannot directly access the VM. NAT is ideal for development and testing, where external access is not required. Bridged networking. This mode assigns the VM an IP address on the same network as the host, allowing direct access from other devices on the local network. This is useful when the web server must be accessible to multiple users within a LAN. Port forwarding. In cases where a web server runs on a VM behind NAT, port forwarding can be used to map a port on the host machine to a port on the VM, enabling external access. Configuring firewall rules is also essential for securing network access. A web server typically listens on port 80, HTTP, and port 443, HTTPS, and these ports must be allowed through the firewall to enable web traffic. Additionally, setting up SSL TLS certificates is recommended for encrypting connections and enhancing security. Optimizing performance for a web server inside a VM. To ensure optimal performance, several best practices should be followed when running a web server inside a virtual machine. Allocate sufficient system resources. A web server requires adequate CPU, RAM, and disk space to handle incoming requests efficiently. Allocating at least 2 CPU cores and 2 GB of RAM for lightweight applications ensures smooth performance, while larger workloads may require additional resources. Use SSD storage for faster read-write operations. Web servers frequently read and write data when handling requests. Storing VM files on an SSD instead of an HDD significantly reduces latency and improves response times, especially for database-driven applications. Optimize web server configurations. Tweaking server settings can enhance performance. For Apache, enabling mod deflate and mod expires helps reduce file sizes and improve caching. For Nginx, setting up gzip compression and configuring worker processes optimizes request handling. Implement load balancing for scalability. For production environments, using Nginx as a reverse proxy to distribute traffic across multiple backend servers enhances scalability and fault tolerance. This setup ensures that high traffic loads are handled efficiently. Regularly monitor and maintain the server. Monitoring server logs, resource usage, and traffic patterns helps identify bottlenecks and prevent downtime. Tools like HTOP, Netstat, and Apache Nginx logs provide insights into server performance and potential issues. Final thoughts. Running a web server inside a virtual machine. Running a web server inside a virtual machine offers a secure, flexible, and scalable solution for web development, testing, and deployment. Whether using Apache for its modular capabilities or Nginx for its high-performance event-driven architecture, virtualized web servers enable developers to experiment, configure, and optimize without affecting production environments. By carefully configuring network settings, optimizing performance, and securing access, virtual machines can efficiently host web applications, making them an invaluable tool for both individual developers and enterprise IT teams.